This is Algebra 2 at Trig. This is day 3 of the first week of school, working on some algebra topics. Here we have a lot of different notes. We have the correlation. You have a positive if they're increasing, decreasing. If they're random, it's no correlation. Our calculator will help us find what's called a correlation coefficient, where you can take the data, and if you get a value that's negative, then you have a negative slope. If you have a value close to 0, then it's pretty random. And if you have a value very close to 1, then it's very linear. The dots would almost make a line. Okay, so we need to approximate. So we look here and we notice that as the x value increases, all the y values go up. It doesn't look super close to 1, but it definitely doesn't look completely random. I would think that this would be a 0.5. This looks very close to 1, so if these are our only options, we would be at -1 for the r value because it's decreasing. Here it pretty much looks all over the board. If you're a small x, you're up a little bit. If you're a big x, you're up a little bit or up a lot. Seems pretty random. So the r value, the correlation coefficient, would be 0. Here we're going to take points. We'll take our calculator. If you hit Stat and go to Edit, we can get rid of the values that are in the calculator. Go up to L1 and hit Clear. Do not hit Delete, hit Clear and Enter. So the x values can be typed in. Slide over, put your y values in. Okay, I got those all typed in now. So now we're going to be able to use our calculator to help us take these values, just like if they were plotted on a graph, and find the line that would best fit that. So we're going to go up to Stat, over to Calc for all our calculations. We're going to look for linear regression. We're expecting this to be a line. We want to know the y equals mx plus b. The values that they use for the calculator is ax plus b. We typically think about it as mx plus b. We want the x values were in the L1. The y values are in the L2. We go down to Calculate. And our a value, which is really your m, and your b value, which is your y-intercept. That would be your best fit line. That line would come extremely close to all of these points. Now we're going to use the equation to figure out the pressure in a 75-year-old patient. Well, 75-year-olds would be larger, so most likely the number is going to be greater. Well, we can figure out the pressure. For a 75-year-old, okay, this would be one way to do it. It's a bit of a approximation because we're rounding all those numbers. So that would be the blood pressure of a 75-year-old. Here, the table shows the number y of alternative fuel vehicles that's used in the United States after 1997. Use a graphing calculator to find the best fit line. We typically say the number of years after 1997. this would be 0, this would be 1, 2, 3, 4, 5, 6, and 7. That'll be the number of years after 1997. 1997, there's 0 years at that point. So you come back to your calculator, go to Stat, go to Edit, you'll go up and clear out both your lists, and then go ahead and type in those values. Type in a 0 for 1998, type in a 1, type in a 2, and so forth. Once you've typed in the times, or the values, for the number of vehicles, for the number of years past 1997, we'll do the same thing. We'll go to Stat, over to Calc. We're doing this all by linear regression. My X values are in list 1, my Y values are in list 2. Your calculator might look a little bit different. It might just say linear regression at the top, and you can hit enter as long as your values are in list 1 and 2. So now we're going to have Y equals 40.869x plus 262.833. The more numbers you use, the more accurate it is. Use your equation to predict the number of alternative fuel vehicles in 2010. So from 2010, before 1997, that gives us 13 years. With the y-intercept of about 262. 13 times the 40.869. And we're going to add the 262.833. So those are the number of cars, number of vehicles. Our next page will be to interpret the correlation, the slope, and the y-intercept. There's a lot of information in here. The correlation can be strong, it can be moderate, it can be weak, it could be positive or negative, and it's a relationship between the x and the y variables. Slope, of course, is the change in your y over x. It can be positive or negative. Your y-intercept, that's when your graph is crossing the y-axis. We're going to come down. The table shows data relating a people's annual income to the number of years they furthered their education after high school. So if you look, the more years you were after high school, in a lot of cases, is more than if you didn't. Find the equation of the best fit line. So we go to our graphing calculator, hit Stat and Edit. We need to clear out list 2, we need to clear out list 1, put in our information. Notice that you can have a couple different values for 0. All the other numbers are different, but they're somewhat close to each other. Okay, we're going to type in the annual incomes. So we've typed in the x values, the y values. We go to Stat, over to Calc, down to linear regression. We have our values in list 1 and list 2. And our equation is going to be y equals 9176.70. If we were to round the 9, that would make the 6 a 7, and x plus 19725.73. That's our equation. Now, to find out a correlation coefficient, we actually have to tell the calculator to find that value. So we're going to have to go to catalog, and catalog is right above the 0 button. So second 0 will take you to catalog. If you hit the D key, which is right here, you see the green D right above the inverse, that jumps it down to the topics that all start with D. And we're looking for diagnostics. Right now they're always turned off. You need to tell your calculator to turn it on. Now your calculator will continue to turn them on until you reset your calculator. You don't have to do this every time. So in stat, we're going to do our linear regression with those points we've already talked about. Now you can see it gives you the same A, the same B, but it gives you these two correlation coefficients. The one we're interested in is just the normal R. So around to the hundredths spot. Tenths, hundredths. So these points would be very close to a line, because it's very close to 1, a positive correlation. The slope, okay, so that means every year's income is going to increase. Every year's, I'm going to change that, additional education increases income by 9,176. That's a dollar sign and some change. What does the Y-intercept stand for? Approximately how much would you make if you didn't have any additional education after high school? The amount of income right out of high school. Now, of course, this is not always a standard rule. You can make great money coming right out of high school, but typically you have to be really involved with something. If you just go with your typical education of right out of high school, you're not going to make as much. If you are an entrepreneur and you start your business or you have some great product, of course there's money to be made. But in most cases, education is going to help you earn that money. Does the Y-intercept make sense in this situation? Can you really have 0 years after high school? I would say yes. We are right out of high school. Sometimes 0 doesn't make sense. If it's the number of breaths that you take in a given day, you don't take 0 breaths in a given day. If whatever the X value stands for, sometimes 0 doesn't make any sense. But it wouldn't make sense here. On the next page, the correlation coefficient. The data is very close to a line. The best fit line is very close. I like to call it like 99%, is very close to the given data. You can phrase it either way. Okay? How many years would you have after 2 years of schooling? So they're saying that our slope is that. We're going to times it by 2. We're going to add in our 19,725. So we're going to take our calculator. We'll take our 9176.70 times that by 2. Add our 19,725.73. So it looks like you may earn $38,000 and some odd amount of money afterwards, after 2 years of college, after 2 years of high school. Okay, here the manufacturer shipped CDs in the United States from 88 to 2002. X represents the number of years since. So it's 0. This is 2 years. This is 4 years. "14 years after 1988 is 2012. The best fit line. We'll go to our calculator. Stats. Into edit. We've got to clear those both out. And then type in your values. No, those aren't the right values. 2, 4, 6, 8, 10, 12, 14. Then type in all the Y values. Now I've typed in all the Y values, the number of CDs, in millions, but I put them there. So our best line, we'll go over to Calc, down to linear regression. That's our values we put into list 1 and list 2. So our equation is going to be y equals 55.30x plus 222.58. That is our best fit line. Our slope is 55 additional CDs every 2 years. That's how much it seems to be going up by. The y-intercept. Our y-intercept in this case is 222. So our y-intercept, when x is 0, at 0 times after, we're selling this many CDs. Well, in 1988, we sold that many CDs. Just gives you an idea. It's close to that, but not so close. This data is not very linear, that's for sure. Does it make sense in the context? I would say no, only because we already have data saying in 1988 1988, 149.7 CDs were sold. And remember, that's millions. So you might call that 149,700,000 CDs were actually sold. But it's 149.7 in millions. So that's why it's a funny number. It's not a 0.7 CD. The correlation is 0.93. I kind of like to think about that as 93% accurate. You can tell that the numbers were falling off here. Predicted value that's going to be shipped in 1995. Well, the X value, 1995 minus 1988 is going to be 7. So when we put that into our equation, we'll get our 55.3 times 7 plus 222.58. We should have about 609,680,000 if you're talking about the in terms of millions. And if you look up here 5 for your data, here you can see all that work. At 7 years, it would be in the 600s. Our data at 6 years shows 662. Here we're getting 609. The data is not perfect. It's about 93% accurate. So that's what we have.